Yes, hello friends. So this is the video tutorial for Leetcode problem of the day, which is 2147. Number of ways to divide a long corridor. So yeah, this is a hard problem, but I don't think this is a hard problem. This should be a medium problem, in my opinion. But yeah, let's see the question. What the question says is, along a long library corridor, there is a line of seats and decorative plants. You are given a zero index string corridor of length n, consisting of letters S and P, where S denotes a seat and P denotes a plant. One room divider has already been installed on the left of index 0 and another on the right of index n minus 1. So basically, like this is a long corridor and there's already a divider here. Give me one second. Yeah. There's already a divider at the start and already a divider at the end. Right. Okay. For each position between index I minus 1 and I, at most one divider can be installed. So yeah, obviously, okay, sorry. Sorry for creating inception. So between any two indexes, obviously, at most one divider can be put, right? Now, what are the valid division that of the corridor that is possible? Is divide the corridor into non-overlapping sections where each section has exactly two seats with any number of plants. There may be multiple ways to perform the division. Two ways are different if they when there is a room divider installed in the first way but not in the second way. Return the total number of ways to divide the corridor. Since the answer may be large, return it modulo 1e9 plus 7 or 10 is to 1 9 plus 7. If there is no way, obviously return 0. So the constraint is that n or the corridor dot length is around 1e5 or 10 is to 5. So uh, when do we call a division valid is that for each division, like for if we put a division here, divider here, we have two divisions, right? This and this. Each of the division should contain two seats. So two seats, and it can have any amount of plants. So here we have two seats in the left, and we also have two seats in the right. Here we have two seats on the left and two seats on the right. Here we have two seats and two seats. Now the plants, there can be any plants in any number of plants in the division. Okay, and we need the total division possible. How can you solve this? Is basically see, if let's say the total number of seats is ns. Now obviously ns should be even because if ns is odd, so let's say this thing is ssps. Obviously, we cannot divide this in a way that every division has two seats, because if we divide it like this will have one seat. If we divide it like this will have one seat. And so, yeah, this would be a power play. So ns should be even and ns should be greater than 0. If none of this thing is true, we can return 0. There is no possible way to divide our corridor. Why ns should be greater than 0? Because see, even if we do not put any divider, even if we do not put any divider, so let's say corridor is like this PPP. Even if we do not put any divider, there's already a divider here. There's already a divider here. So the we have already divided it into a room, and this room does not have two seats. So this is a problem. Okay, this is a problem. So both of these condition has to be true. Okay, let's say if both of these are true. So let's say like this case, S S. This is double P S P S. Okay. Now we know that every room has to have two seats. So now if there is two seats here, now there are some plants. So where can we put a divider? Can we put a divider here? We can put a divider here. Okay, so can we put a divider here? We can put a divider here. We can put a divider here. Can we put a divider here? No, because now it will this room would have three seats. So how many choices of dividers you have is basically count of p plus 1. Does this make sense? Because we can put before it, before all the p's, we can put in between all the p's, and we can put after all the p's. So that is 1, 2, 3, and we have two p's, right? So that is count of p plus 1. This is the choices. But the thing to note here is that this is choices for this room. Now the next room. So let's say this is SPS. Okay. So SPS, and let's say this is SSP. Yeah, something like this. Okay. So here we see two seats. Then we go to number of plants. So the idea is basically first find your two seats, then find all find p's. So find how many p's you can. So here we find our two seats, then we find a p, and then we get a count of p plus 1. That is, you have three choices here. You have three choices here. Now you again go, because see, the the divider has to be put in between this, because you cannot delay your corridor after it, because then this room would have three seats. So at worst you can put it here or like here. So you have three choices here. Now for the next thing, you will start from here. Again, you will find your two seats. So you find one seat. Then this is not a plan. This is not a seat. So you will skip it. Divider cannot be put here. Why divider cannot be put here? Again, this would have three seats. So yeah. So you will again find your 2s. So you find your 2s. You come here. Then you can search for p. Here there is no p. So the choices you have is only one. Right. Then again you find your 2s. So you start again from here. 2s, then you find, and then you get a count of p 1, and you will say there's two choices. Either you can put here, either you can put here, but this is wrong. Why this is wrong is, see, if we put a divider here, this will form a room, right? This will form a room, and this will not have two seats. Because obviously this does not have two seats, because this has zero seats. This is at the end. So the actual choices for the last in the room is actually only one. So here, for the last, we will see that does not matter on the number of plants. The last room here will only have one choice, because you have to put a divider here. You cannot put a divider here, right? So you can implement this two way. One is, if this is the last room, then you do not take the choices for the last thing. Otherwise, what I did is basically I removed all the plants at the back, because these are not contradicting anything. So I just remove this p. If this p is there, I just pop this back. So basically, I convert my string to SS, PP, SPS. So we basically saw there's three choices here. There's three choices here on putting the divider, and then SPS, SS, right? SS. And here there are one choices. Now the total answer would be what? The choices for this into choices of the next one. So if let's say there was one plant here, then we'll say that there's two choices for this. So the final answer is basically multiplication of all the choices. Or I can say it like this: multiplication of this becomes pi, but yeah, multiplication of all the choices. If you are not able to understand, maybe looking at the code, you will be able to understand it more. So multiplication of all the choices under modulo 1e9 plus 7. 1e9 plus 7. Right. So here it would be 3 into 2, 3 into 2, that is 6. So see, because you can put a divider here, you can put a divider here, then you can put a, that's it. Yeah. Or you can put a divider here, you can put a divider here. So that is for each of these. There are two choices for this. That is why here for this, again it will have two choices, either here or either here. Again for this, so like three choices for this, two choices for this. Basic basic PNC will make sense here. So let me show you the code how I implemented it. So I calculated the total number of seats here, because we'll have to check on this. If seats are odd, then we'll have to return 0. There is no way to divide a corridor. And if seats is 0, then again we'll return 0. So I calculate the total amount of seats, and do this check. Then this is a valid case, but again, as I said, the last piece do not actually give you a choice. So either you can explicitly in the code handle here, like if this is a last corridor, then do not add choices into our answer. The simpler way I thought of is just remove the last plants. So I pop the last few plants, because these do not actually give you a choice. Like here, for this case, you cannot put a corridor here, because this will create a room, and then again there won't be two choice, seats here. So I just remove the final plants from the back till there is a plant, like here. This is P, so this is P, so I pop this, but this is an S, so I stop popping now. Now I go over all these seats in a way that first I find my two seats. So as do here, that till count of seats is less than two, I find my seats, and after it I get all the choices of plants, so the number of plants. So I only go till it's a plant, and the total choices would be uh, plant total count of plant plus one, and I initialize my choices as one. So for each plant, it will be, for if there's one plant, it would be one plus one, that is two, right? And I finally added to answer, and as I said, the choices would get multiplied because they are independent of each other. And this is like a bit of PNC that you should know. And finally, we can return answer. Yeah, this is pretty simple question. I think this should not be an hard. But yeah, thank you for watching. If you were able to understand anything, give me a like and subscribe. All of those things. Bye bye.